we have to now formally introduce the rule of performing the substitutions, and there's some additional point that we need to take into account when we perform substitution in order not to run into the error that we seen in the last slide. So there are 4 cases that when we apply substitution to a lambda term. For example, when we apply a substitutions to a variable x, and if the variable in the substitution agree with this x, I mean they're the same x, then we can just output the E1, which is the things that we're going to replace x with. Otherwise, if the two variable doesn't agree, and we just keep the variable unchanged. Okay. And the third case, where we try to apply substitution to a function application, okay, we just perform the component-wise substitution. We just pass and propagate the substitution to the E2 and the E3. Okay. Finally, in the last case, when we apply substitution to a lambda abstraction, then by right we need to apply the substitution to the body of the function. Okay, in this case, we just propagate the substitution to E2, which is the body of the lambda abstractions. But there is a condition here. So this is only possible if this is true. If in the first place, y, which is the lambda bound variable or the lambda variable that introduced here, it must not equal, okay, it must not be the same as the one that we're going to replace, which is x. Okay, if y is equal to x, this rule will not be applied. Okay, the second condition is that y, okay, again the same thing, the lambda bound variable that introduced here must not appear to be the free variable in E1. Okay, this is avoid cases that we have mentioned in the previous slide, that we might mistakenly capture any y that come from E1 in the current scope. Okay. So what happens if we indeed have a program that doesn't satisfy this? Then we need to apply another rule called the alpha renaming. So alpha renaming is simple. We simply just rename consistently the lambda bound variable in its occurrence in its body, as long as in the same scope with a different name. For example, early on we have seen this problematic program. If we run it using lambda, if we use the beta reduction naively, we get into a funny outcome, okay, or unexpected outcome. And to avoid that and make sure that this won't be the case, then we have to enforce our substitution rule. So if we enforce the substitution with this additional checks, and this will get stuck, we can't apply the substitution at all. So one way to make it reducible is to rename, for example, this lambda bound variable y into z. Okay, you have to consistently replace its use its body into the new name. Okay, so this process is called alpha renaming. So typically, one strategy is that we try to apply beta reductions. So before we apply beta reduction, we observe whether there's any need to apply the alpha renaming.